What's up, guys? And hello. So, hey guys, welcome back to a new video. So, we are going to starting programming. Let's go, boys. My last words. Wow. Interfacial best healthy recipe for kids must.
First, take a look at the contract hack me. Up at top, it has some state variables. An address type called lib, another address type called owner, and a unit state variable called some number. The constructor sets the address for the lib and but unsafe delegate call. When delegate call is used to update storage, the same state variables have to be declared in the exact same order. But what happens if the state variables do not line up? For example, you forgot to declare a state variable, or you declared it in the wrong order, or you declared the wrong type. In this video, I'm going to show you an example of unsafe delegate call when contract A delegates call to contract B to update the storage, but the storage layout is different between contract A and contract B. Let's find out how this can be a dangerous mistake. Here we have two contracts, contract lib and contract hack me. Let's first take a look at the contract hack me. Up at top, it has some state variables, an address type called lib, another address type called owner, and a unit state variable called some number. The constructor sets the address for the lib and owner to message.sender. Let's take a look at the contract hack me. Up at top.
What's up?
Stay at hotel and enjoy a pizza night. Book now on the OYO app. Yeah, bro. Good night. Congratulations. Yeah, निरंकारी गेमर. हाय ब्रो. मी आली म्हणून झाला चिकन.
It has a function called do something, which takes a unit as input and then calls the function delegate call on the lib address. Inside the delegate call, it makes a request to call the do something function. So this line of code will try to call the do something function at the address of lib. Later, when we deploy this contract, we'll pass in the address of the lib contract above into this constructor. So now let's take a look at the lib contract. What does it do? The lib contract has a single state variable called some number. And then it has a function called do something that updates the some number state variable. Now notice that the hack_me contract declares 3 state variables, but the lib contract only declares a single state variable. So I've told you that if you want to update the state variables inside the hack_me contract using delegate call, then the contract that is receiving the delegate call must also declare the same state variables in the exact same order. And in this case, you can see that the state variables in the lib contract and the hack_me contract do not line up. So what can go wrong? Well, your challenge here is to update the owner state variable inside the hack_me contract. The hint here is that this contract is using delegate call to update a state variable. It's trying to update the third state variable inside the hack_me contract, but the actual state variable that is being updated here is the first state variable, which turns out to be the address of the lib contract. Go ahead and pause the video here and give it a try. Alright, so let's think through how we can update the owner state variable. Well, when we call this function do something, it will call the function do something inside the lib contract by using delegate call. And the function do something will update the state variable some number. Now inside this contract, some number is the first state variable. So when the function do something is called using delegate call, it will update the first state variable. In this case, the first state variable inside the contract that is making the delegate call is an address to the lib. So by calling this function, this will update the first state variable, which is the address of the lib. This means that we can update the address of the lib by calling the function do something. Then we can pass in the address of the contract that we want to point the lib state variable to. Now notice that I said we're going to be passing in an address here. But this function takes in a uint for the input. So here we'll have to be a little clever and cast the address to uint. Once the address to the lib contract is updated to a contract that we specify, we can call the do something function again. But since the lib now points to the address that we set, it will delegate call to the contract that we specify. So when this delegate call calls the function do something at the address of lib, using the storage of hack_me to update these state variables. That's the basic idea of how we're going to update the owner state variable. Let's now put this in code. We'll name this contract attack. The first thing that we'll do is copy the state variables from the hack_me contract. So from the hack_me contract, I'm going to copy all of the state variables and then paste it inside the attack contract. The reason why we're doing this here is so that when we write the code to update the state variable targeted at the hack_me contract, this will make sure that we are updating the correct state variable that we want. Next, we'll declare the state variable for the hack_me contract. And then we'll set the hack_me state variable to the hack_me contract above when we deploy this contract. Now earlier I said that the contract calling delegate call and the contract being called, the state variables have to be the same. So you might have noticed that the state variables in the hack_me and the attack contract are now different. Here inside the attack contract, we have an extra state variable called hack_me. But this won't be a problem here, since all of the state variables that we want access to inside the hack_me contract are declared in the same exact order. So this state variable here, hack_me, will be stored in the storage location where the original contract, hack_me above, does not have access to. Just to clarify what I mean here, the first 3 state variables are stored in slot 0 to slot 2. This is true in both the hack_me contract and the attack contract, but the last state variable hack_me is stored in slot 3. Now, if you look inside the hack_me contract, you can see that there is no state variable stored in slot 3. So declaring a state variable here will not cause any problems in the original contract. So that was an explanation of why we can have state variables that look a little bit different, as long as the state variables that we are concerned with are the same. All right, moving on, let's now write the function that will actually hack the hack_me contract. The first thing that we'll do is call the do something function inside the hack_me contract. We'll want to pass the address of this contract. But since the function takes in a uint as input, here we'll cast the address as uint. On the next line, we'll call the same function again and then pass in some number. It doesn't really matter here, so I'm just going to pass in 1. When this line of code is executed, it will delegate call to call the function do something inside this contract. So let's write the do something function inside this contract. The do something function is the function that will be called when the hack_me contract delegates call. First, we'll make sure that the do something function here has the same function signature as the do something function above. So the name is the same, and the input is the same, and the function visibility is the same. Now, when this function is called, we want to say something like the owner state variable is equal to this contract. But remember that this function will be called using delegate call, so the context will be preserved to the caller. Okay, so let's figure out which contract is going to be calling this function so that we'll be able to put the correct value here and update the owner state variable to this contract. Our starting point is line 53, hack_me.doSomething, which means that this contract, the attack contract, is going to call the hack_me contract. The hack_me contract will delegate call to the attack contract, and this function here will be called. This means that inside the hack_me contract, message.sender will be equal to attack. And when the hack_me contract calls the attack contract using delegate call, it's going to preserve the context, so message.sender will still be equal to attack. This means that when this function is called, the address of this contract is equal to message.sender. So here we can update the owner to this contract by saying owner equals message.sender. That completes the code that will update the owner state variable inside the hack_me contract. Let's go over how this exploit works. First, Eid calls the attack function. This will call the do something function inside the hack_me contract above. And we'll pass in the address of this contract, cast it into uint. So this line of code will call the function above over here. And here num will be the address of the attack contract, cast it into uint. The function will use delegate call to call the do something function inside the lib contract, which means that this function here will be executed, and it's gonna update the first state variable. Now, since here we passed the address of the attack contract, this line of code will update the first state variable to the address of the attack contract. Back inside the hack_me contract, this means that the first state variable, which is equal to lib, so this address will be updated to point to the attack contract. That completes the execution of line 52. In line 53, we call the same function again. And this time it doesn't really matter what number we pass in. Now again, this line of code will call the do something function inside the hack_me contract. So this will call the do something function again inside the hack_me contract. And again, it uses the delegate call to call the do something function. But now the state variable lib no longer points to the contract above, since the first call to do something updated the lib state variable here. And since it points to the attack contract below, this line of code will call the do something function inside the attack contract. And it will execute this code here. which will update the owner state variable. Now, since all of this runs inside the context of the hack_me contract, the owner that's going to be updated is not the state variable here, but the state variable inside the hack_me contract. And that's how you update this owner state variable, by making two delegate calls. The first one will update the address of the lib contract to point to this contract,